So some of you actually asked me a pretty cool question the other day, and that was if we take a look at the mean excess loss, which we learned about in chapter 2. So the mean excess loss is given as the mean value of the excess given that we have a loss that exceeds the deductible. And you guys actually kind of asked me, well, isn't that the same as this mean of x minus d plus? And the funny thing is, the answer is no. And in order to understand that, we can first and foremost try to look at the definitions. So this thing down here, as we noted earlier, it is the mean of x minus d multiplied by an indicator which only allows this to be x minus d in the case that it's x minus d is positive, so in the case that x is greater than d, and otherwise the stochastic variable inside here is 0. However, the mean excess loss is by definition the mean of x minus d restricted to this event. So also we multiply by the indicator that x is greater than d. So the numerator up here is actually the same as what we just calculated. However, down here, we should also divide with the probability of whatever we condition on when we find a conditional expected value. So the mean excess loss and this expected value here are actually two different things. They are two completely different things. And how should we understand that? Well, let's say we have an insurance company, because sometimes the easiest way to understand expected values is to think of them as an average over many claims. So let's say we have an insurance company here, and they have one type of bike insurance where the deductible, let's say, is 1,000. So if your bike is stolen or damaged for a loss greater than 1,000, then you pay 1,000, and the rest, the so-called excess, is then paid by the insurance company. So what if I ask this question? What is the average payout for the insurance company? What is the average payout for the insurance company? Should I then say it is equal to this thing, or should I say it is equal to this thing? So when the insurance company thinks of payout, then we could actually say, well, it kind of depends, right? Are we looking at the average payout among everyone who has experienced the claim? Or are we looking at the average payout among those who have experienced the claim high enough for the insurance company to pay? And that is the main difference. So the mean excess function up here, it tells us that, well, the way we should interpret this is the mean of x minus d multiplied by the indicator of x being greater than d, like so, divided by the probability that x is greater than d. This is the average payout It is the average payout among those claims that exceed deductibles. Among those claims that exceed deductibles. So among all claims where the insurance company needs to pay something. However, if we only take the numerator, this thing here, then this stochastic variable can attain certain values of 0. So this is the average payout over the entire population of customers. And that is where the difference lies. So it's a very subtle difference, but it's an important difference to understand. And that was problem 4.1. Think a little bit about this, and if you want to read more about it, there's a link in the chapter 3 section of the website that you may click on. I think it links to an external blog of some kind where they also explain the difference in detail.